Today we will discuss time series analysis, and this is the lecture series 1. This is a part of module 6 of statistical methods of MA Economics part 2. I am Dr. Rashmi Akhori from Department of Economics, College of Commerce, Arts and Science, Patna. What are the learning objectives of this lecture? After going through this lecture, you will learn what is time series analysis and what are the components of time series analysis. It is a statistical technique. Basically, it is one of the forecasting technique. It deals with time series data, or you can say it is a trend analysis. When we say time series data, it means that data is in a series of particular time periods or intervals. The data is considered in 3 types. One is time series data, a set of observations on the values that a variable takes at different times. Then cross-sectional data, data of one or more variables collected at the same point in time. Then again, pool data, a combination of time series data and cross-sectional data. Now, in detail. Cross-sectional data, or a cross-section of a study population in statistics and in econometrics, is a type of data collected by observing many subjects such as individuals, firms, countries or regions at one point or period of time. The analysis might also have no regard to differences in time. Then time series data means that data is in a series of particular time period or intervals. Panel data, you can say, are multidimensional data involving measurements over time. It contains observations of multiple phenomena obtained over multiple time periods for the same firms or individuals. We must know what are the differences between these types of data. Now, most forecasting techniques involve the use of time series data. In a simple analysis, a time series is assumed to contain the following components. The first one is trend or the secular trend. The secular trend means long-term tendency of the time series to move in an upward or downward direction. So it can be defined as a consistent long-term change in the average level of the forecast variable per unit of time. Consider the following figures showing the data on the color TV licenses issued over the period of time. You see here, in this diagram, when we plot the data, we find a trend, and this trend shows upward sloping, or you can say it is upward trend. Second is seasonal component. Seasonal variations are caused by the seasonal influence of spring, summer, autumn, winter on business and economic activities. Seasonality may also refer to a season in the context of a specific variable on which the data is recorded. For example, in touring business, season may mean the months of June, July, and October, November, when number of touring people increase considerably. Thus, seasonality may refer to repetition of a pattern by months, by weeks, or even by days of the weeks. Consider the following figure showing the mean temperature in town A over the period of time. So you see here how this temperature is depicted in town A. There is variation. Third is the cyclical component. Cyclical variation, which are also generally termed as business cycles. They are the periodic movements in the time series around the trend line, and these are the upswings and downswings in the time series, and that are observable over extended period of time. Neither the magnitude nor the frequency of occurrences of these cycles are uniform. For example, high boom in the stock market in India for a span of 4-5 years in 1990s caused by the Harshad Mehta factor can be considered as a cyclical component affecting the activity level of a stock market over a period of time. The cyclical fluctuations are like waves which come and go. At times, the cyclical waves prevails for a long time, say 50 years, but these long waves are difficult to be distinguished as they get mixed up with the trend line. Fourth one is the irregular component. This is random and non-systematic variation affecting time series through such unpredictable events as strikes, breakdowns of plant, non-seasonable illness, bad weather, etc. So these variations either go very deep downward or too high upward to attain peaks abruptly. These do not occur frequently and are less important than the cyclical or seasonal movement. Now, after studying components, we will focus on the models of time series analysis. Analysis of time series involves decomposition of the time series into its four components listed above or which we have discussed just now. Our objective is to estimate and separate the four types of variations and to bring about the relative impact of each one on the overall behavior of the time series. There are two models of decomposition of time series. One is additive, another is multiplicative. What is additive model? This model is used where it is assumed that the four components are independent of one another. Actually, independence is the characteristics of this model. You can say independence is said to exist when the pattern of occurrences and the magnitude of movements in any particular component are not affected by the other components. Under this situation, or you can say, sorry, under this assumption, the four components are uh, arithmetically additive in the sense that the magnitude of the time series are the sum of the separate influences of its four components. For example, we will see how it is so. If it is taken to represent the magnitude of the time series data at a time period t, then y t can be expressed as, you see here, y at the time period t is equal to trained t, which is t plus, you can say it's c plus s plus r. Now where t represents the train variation, c represents cyclical variations, s represents seasonal variations, and r represents random variation. So the additive model is y equals to t plus c plus s plus r at time period t. Now, what is the multiplicative model? This model is used where it is assumed that the forces giving rise to the four types of variations which are interdependent, so that overall pattern of variation in the time series is the combined result of the interaction of all the forces operating on the time series. So in this way, according to this model, time series are the product of its four components, that is y equals to t into c into s into r. As regards the choice between the two models, it is generally the multiplicative model which is used more frequently, and the reason being that the most business and economic time series data are the result of interaction of large number of forces which individually cannot be treated responsible for generating any particular type of variations. Since the forces responsible for one type of variations are also responsible for other type of variations. So it is the multiplicative model which is ideally suited for the purpose of decomposition of a time series. Now, today we have discussed what is time series analysis, what are the different components of time series, and what are the models of time series. Thank you.